So it's Johnny again, back at NeurIPS. I'm from the Polaris team, and I'm just making my way through the posters again, and I saw a really interesting poster in a paper talking about quantum chemistry data set as well as a benchmark for neural network potentials. So I'm here with one of the authors of the paper, Alina. Do you want to start by just quickly introducing yourself?
Yeah, hi everyone. My name is Alina Tubalna. I'm an elite in Artificial Intelligence Research Institute, and this is my collaboration with AI and chemistry team from our institute on new data set of drug-like molecules and benchmark of neural network potential for quantum chemistry problems.
Amazing. Maybe to start, do you want to just share a little bit more about what are neural network potentials and why is it something that people are interested in, especially in maybe a drug discovery context?
Maybe let's start with what is actually quantum chemistry. So basically, quantum chemistry is a very fundamental field where study interaction between atoms and electrons in the molecules. And the main idea that they have a really nice fundamental theory, but it's very computationally expensive and hard to find. Neural network potentials and neural networks were designed to predict energies, potential energies, and forces between atom and electrons in order to figure it out what's the characteristic of a new compound.
Amazing, amazing. And so what are some of the challenges in terms of working with existing data sets or benchmarks in the field of neural network potential development?
So mostly existing benchmarks is very small. So traditional neural networks for AI, especially for quantum chemistry, they train on small molecules and they face distribution shift problems when you not generalize well for a new compounds. And mostly no of existing data set include a lot of information about energies, forces, and Hamiltonian matrices with alternative for quantum chemistry results. And we combine a lot of data in our data set with traditional DFT method in order to train neural network and benchmark them well on for the specific task.
Amazing. And walk me through a little bit about the data set, the work that went into the data set. So you curated a new data set, you added in additional energies and labels. Walk me through the data set that you're presenting here.
Yeah, sure. So this is a drug-like molecules data set. So basically we collected molecules from very existing Moses data set, which looks like drugs and existing compounds on the market. Then for each molecule we computed conformations, which is 3D representation of molecules. Then for each of the conformation we basically cluster them, picked centroid, and then decided which would gonna stay in the data set, compute a lot of characteristics for it, like energies, forces, Hamiltonian matrices, overlap matrix, in order to build a benchmark for three major tasks, which is basically forces predictions, energy prediction, Hamiltonian prediction, and the most interesting task for me, it's actually energy optimization of geometries.
Amazing, awesome. And so we'll leave a link to the paper down in the description below. You can access the data set and the benchmark. All of the links are in the paper, and you'll find that in the description below. Thank you so much for the time.
Thank you for your time.
Thank you.